They are used in every single form of mass transportation in the United States, from the cars that we drive to trains, planes. Even the humble bicycle uses this substance as its major structure because it provides both strength for the vehicle and safety. These substances undergird every major skyscraper in the world. The crushing force of the weight of those buildings pushing downward, yet these substances do not bend nor break. These substances are used to manufacture weapons of war, guns, bullets, tanks. They're also used in an industry that saves lives, the medical industry, in things like needles and x-ray machines and MRI scanners. What type of substance am I talking about? I am talking about metals. And what we're going to be doing over the course of the next several lessons is looking at the particular groups of metals on the periodic table and what their characteristics are, how they're found in nature, and what their human uses are. We're going to start with the most reactive group of metals on the periodic table, found on the far left side, the alkali metals. And again, the alkali metals are a group of elements that have similar characteristics on the periodic table, and we find this group of elements in the far left column, and all of these elements are similar in that they are all extremely reactive. But why are they all extremely reactive? Well, here's something interesting about the elements on the periodic table. The characteristics of the elements aren't determined by the number of protons, even though, remember, the number of protons is what gives an element its identity. The reason an element has the characteristics that it does is because the protons attract a certain number of electrons in a characteristic way. In this case, for the alkali metals, the protons attract electrons in such a way that there is always one electron in an outer energy level in the electron cloud far away from the nucleus. Hydrogen just has one electron, period. Lithium, the next metal down, has 3 total electrons. One of them is farther away from the nucleus than the other 2. You'll see on the page the element sodium, which is explosively reactive in water, has a lot of electrons. It has 11 total. The 11th electron is found far away from the nucleus in an outer energy level. All of the alkali metals share this in common. They have one electron that is far away from the nucleus. Here's what happens that makes them so reactive. In nature, that electron will be easily taken away. It gets stripped off of the atom and causes it to very easily form a 1+ ion. When you put pure sodium metal in water, that sodium metal has all 11 of its electrons, including that one that's far away from the nucleus. But it can't stay in that state as sodium metal for very long because it's so easy for water to just rip away that electron that's far away from the nucleus. And that's what that intense chemical reaction as sodium contacts water and blows up, that's what that reaction is. That electron getting ripped away from every single sodium atom. And then the sodium atom forms a 1+ ion, and then it will react with other substances to form different things. So what makes the alkali metals similar is that they all have one electron far away from the nucleus. That electron is very easily lost in a violent reaction, which causes it to form 1+ ions. And then in nature, these alkali metals are so reactive, you just never find them by themselves. They're always reacted with other things to make brand new substances. The characteristics of the alkali metals, as we've been saying throughout this lesson, they are highly reactive, explosively reactive, extremely reactive. They react very easily with other substances on the periodic table, including things like the halogens, chlorine, bromine, iodine, with oxygen, with nitrogen, and they will even react with molecules or crystals that have already been formed, like water molecules. They are just extremely reactive substances in their pure forms. When compared with other substances on the periodic table, the alkali metals are found to have fairly low melting and boiling points. It's not too hard to turn them into liquids and gases. It does take heat, it takes fire, but it does not take an extremely hot fire to melt and to boil the alkali metals. And then finally, the alkali metals have the same properties that all metals have. They conduct electricity, they conduct heat, they can easily be pounded into flat sheets or drawn into thin wires. For elements on the periodic table, however, the alkali metals having that one electron on the outside to give it some extra volume, the alkali metals aren't as dense as other metals on the periodic table are. Hopefully this lesson has taught you a bit more about the alkali metals, especially the fact that the alkali metals have one electron in their outer energy level, and that's what gives it its characteristic property of being extremely reactive, as that outer electron gets stripped away and the atoms form 1+ ions, which are then available to bond with other substances.